Good morning, students. In this class, I am going to teach you the second unit, Hamilton functions, and what are the applications of Hamiltonian function, how Lagrangian equation can be derived from Hamiltonian function, then using variational principle, how the Hamiltonian equation of motion can be derived. Afterwards, what are Poisson brackets? What are canonical transformation for Hamiltonian equations, etc. In this class, I am teaching about Hamilton's functions. In earlier lecture or earlier class, we saw about Lagrangian equations of motion. We know that Lagrangian equation of motion is nothing but it is represented by the letter L, that is equal to T minus V. That is, T is the kinetic energy and V is the potential energy. T is the kinetic energy and V is the potential energy. This Lagrangian equation of motion or Lagrangian of a system, Lagrangian of a system depends upon three variables. This Lagrangian of a system depends upon three variables. One is the position coordinate, another one is the velocity coordinate qk dot, another one is time. So a Lagrangian equation or a Lagrangian function will depends upon three coordinates. One is qk, another one is qk dot, another one is t. These are all called as generalized coordinates. These are all called as generalized coordinates. So Lagrangian equation depends upon the generalized coordinates. This L can be written as L is equal to L is a function of qk, qk dot and t. Let it be equation number 1. Now we know the Lagrangian equation of motion, that is d by dt of dou L by dou qk dot minus dou L by dou qk is equal to 0. This we already saw in the earlier lecture or earlier class. This is Lagrangian equation of motion, that is d by dt of dou L by dou qk dot minus dou L by dou qk, that is equal to 0. Here, why Hamiltonian function should be needed and what are the disadvantages of Lagrangian equation? Basically, the Lagrangian equation depends upon Lagrangian equation depends on, first point is it is depends upon the variables, that is generalized coordinates. Also, it is a second order differential equation. It is a second order differential equation. So solving this second order differential equation is a complex one. Solving a second order differential equation is a complex one. It is very difficult. Also, it does not give the details about the principles of quantum mechanics. It does not give the details about quantum mechanics. So these are the disadvantages of Lagrangian function. So to overcome these Lagrangian function discrepancies, Hamiltonian function should be used. But this Hamiltonian function is a simple function and it is solved easily and it is independent of the variables. Here in Lagrangian equation it is dependent of variables. What are the dependent variables? Qk, Qk dot and T. That is Qk is nothing but the position coordinate and Qk dot is nothing but the velocity coordinate. So both are dependent to each other. But in the case of a Hamiltonian function, these are independent variables. We are using independent variables. So what is the Hamiltonian function? It should be represented by the letter, Hamiltonian function is represented by the letter H is equal to H of Qk, Pk and T, where H is the Hamiltonian function, this Qk is the position variable, Pk is the momentum variable and T is the time. So Qk is the position variable, Pk is the momentum variable and T is the time. Here this position variable Qk and Pk is independent of each other and also time is independent of all these three quantities. Therefore, Hamiltonian function is independent of the variables. Hence, Hamiltonian function is used to describe the motion of the particle instead of Lagrangian equation. Okay, right. Now, how to get this Hamiltonian function from this Lagrangian point? Lagrangian function. We know that from this equation L is equal to L of Qk, Qk dot T. Then another equation d by dt of dou L by dou Qk dot minus dou L by dou Qk, that is equal to 0. You remember these two equations. Now, differentiate that equation 1 with respect to, differentiate this equation 1 with respect to dt. Okay. Now, what will come? So, 1 will become dl by dt, that is equal to, now how you differentiate? There is a L is the function of three variables Qk, Qk dot and T. So first partially differentiate dou L by dou Qk with respect to dou Qk and dqk by dt plus dou L by another variable dou qk dot, then dqk dot by dt plus then dou L by dou T into dt by dt. Okay, now you understand. So first equation 1 should be differentiated with respect to dou L by dou qk dq by dt plus dou L by dou qk dot dqk by dt plus dou L by dou T by dou T. Here now dou L by dou qk, this dqk by dt is nothing but qk dot, okay, plus dou L by dou qk dot, this dqk dot by dt is nothing but qk double dot plus dou L by dou T, this dt by dt is nothing but 1. So this equation becomes dl by dt, that is equal to dou L by dou qk dot plus dou L by dou qk dot into qk double dot plus dou L by dou T. Make this equation number 3. Okay. Now, this equation we know from the Lagrangian equation 2, equation number 2. Equation number 2 is nothing but d by dt of dou L by dou qk dot minus dou L by dou qk, that is equal to 0. That is the third equation. So from the third equation, sorry, that is the second equation. From the second equation you convert this. d by dt of dou L by dou qk dot. This minus sign will come to right hand side, then it becomes plus sign. So d by dt of dou L by dou qk dot into dou L by dou qk. This is equation number 4. Now this value of dou L by dou qk is substituted here in the equation 3, that is in this place, that is dou L by dou qk. Instead of dou L by dou qk, you substitute d by dt of dou L by dou qk dot. So that equation number 3 becomes dl by dt, that is equal to d by dt of dou L by dou qk dot and qk dot plus dou L by dou qk double dot into dou qk single dot qk double dot plus dou L by dou t. Now you make it this equation, this point, that is dou L by dou qk dot as a second function, and this is one function. So you make it here. This is one function, qk dot is one function, then dou L by dou qk dot is the another function. We know uv formula, that is d by dt of uv, that is equal to d by first function d by dx of second plus second function d by dt of first. So we know this formula. Now you see here, this portion may be written as, you see, dl by dt, that is equal to d by dt of qk dot dou L by dou qk dot plus dou L by dou t. That is, you consider this is the first function and this is the second function. You see d of uv method, d by dt of this first function and second function. What will be the result? First function d by dx of second plus second function is this second function d by dx of first. So differentiate this qk dot, what will get? Qk double dot. Therefore instead of this, I am writing this equation in this format, that is d by dt of, these two are same, d by dt of qk dot dou L by dou qk dot plus dou L by dou t. Understand? So this is equation number 5. Okay. Now to find out the value of this dou L by dou qk dot, now we want to calculate the value of dou L by dou qk dot and substitute the values here and we will solve. Now you see, we know that L is equal to T minus V. Now differentiate this equation with respect to qk dot. Differentiate this equation with respect to qk dot. So what will get? Dou L by dou qk dot, that is equal to dou T by dou qk dot minus dou V by dou qk dot. Okay. So dou L by dou qk dot, that is equal to dou T by dou qk dot minus dou V by dou qk dot. Here V is the potential energy, T is the kinetic energy. What is the formula for kinetic energy? T is equal to half mv square. That is, qk dot is nothing but velocity. So this kinetic energy depends upon the velocity. Here qk dot, potential energy, what is the formula? V is equal to mgh. So mgh. So there is no use of this velocity. This potential energy does not depends upon the velocity here, but kinetic energy will depends upon the velocity. Therefore, what will happen? Dou V by dou QK dot will become 0 because it is not independent of velocity. Potential energy is the independent of velocity. Therefore, dou V by dou QK becomes 0. Therefore, in the above equation, what will happen? Dou L by dou QK dot, that is equal to dou by dou QK dot of T is nothing but kinetic energy. What is the formula? Of mv square. So how can we write? If there are more number of functions, so summation of k of mk qk dot square. This is minus 0 because this term becomes 0, therefore this becomes 0. Understand this equation? Dou L by dou QK dot, that is equal to dou by dou QK of, instead of T I am writing of mv square, that is if there are n number of k number of particles, so of mk qk dot square minus. So this become dou L by dou QK dot, that is equal to dou by dou QK dot of summation k of mk qk dot square. Now, if you are differentiating this qk dot, summation of k, then this of, then mk, you differentiate this, what will become? 2qk double dot, okay? 2qk double dot. When you are differentiating this qk dot square, then the differentiation of this becomes 2qk double dot. So from this 2 cancel. So dou L by dou QK dot, that is equal to summation of k mk qk dot, mk qk dot, or dou L by dou QK dot, that is equal to, this is m, this is v, okay? So mv is nothing, product of mv is nothing but the momentum. Therefore, this can be written as pk, okay? This value can be written as pk. So dou L by dou QK dot is pk. This is equation number 6, and you remember this equation forever, this in the second unit. So in many places I will write dou L by dou QK dot, that should be is equal to pk. So this momentum coordinate pk is equal to partial derivative of the Lagrangian function L with respect to qk dot. Now substitute this dou L by dou QK dot is equal to pk in equation number 5. In equation number 5. So equation 5 becomes dl by dt, that is equal to d by dt of qk dot pk plus dou L by dou t, okay? So substitute that value of dou L by dou QK dot is equal to pk in equation number 5, and you will get dl by dt, that is equal to d by dt of QK dot pk plus dou L by dou t, or dl by dt minus d by dt of QK dot pk is equal to dou L by dou t, okay? Now this d by dt common இருக்கு, you remove this outside. So d by dt of L minus pk qk dot, that is equal to dou L by dou t, or d by dt of pk qk dot. So this minus will become here, so this become minus L, that is equal to here minus dou L by dou t. So this is equation number 7. Okay, right. Now d by dt of h, that is equal to minus dou L by dou t. This is an important equation. So dh by dt is equal to minus dou L by dou t. That is differentiation of a Hamiltonian function is nothing but or is equal to the negative value of partial derivative of Lagrangian function with respect to t. So dh by dt, that is equal to minus dou L by dou t, where h is equal to pk qk dot minus L. This is called Hamiltonian function. This is called Hamilton's functions. Okay, so h is equal to pk qk dot minus L. If there are more number of coordinates, then we may use this summation of k. So summation of k pk qk dot minus L, this is called what? Hamiltonian function. This is called Hamiltonian function. So make this equation number 8. So this is the Hamiltonian function. So you remember this function. Okay, this function. Now what is the physical significance of this Hamiltonian function? What is the physical significance of this Hamilton's function? Now from equation 8 we know that h is equal to summation of k pk qk dot minus L, or we may write it h is equal to summation of k mk qk dot into qk dot minus, instead of L we may write t minus v. Okay, for pk is nothing but mk qk dot, then this qk dot minus, instead of L you may write t minus v, or h is equal to summation of, multiply this, so mk qk dot square minus t, then minus of minus plus v, make it equation number 9. But we know that t is equal to summation of k of mk qk dot square. Therefore ये cross multiply करेंगे 2t, that is equal to summation of k mk qk dot square, equation number 10. Therefore now summation of k mk qk dot square here in equation number 9. So you substitute, instead of this you make it as 2t. Therefore equation 9 becomes now h is equal to, instead of this term you substitute 2t. Okay, so 2t minus t plus v. Okay, or h is equal to t plus v. You see h is equal to what? t plus v. What is L? L is equal to t minus v. Okay. Here H is equal to L is equal to t minus v, but H is equal to what? T plus v. T is the kinetic energy, V is the potential energy. So which is nothing but total energy. Okay. So total energy of the system is nothing but Hamiltonian function. The total energy of the system is the Hamiltonian function. But in the case of Lagrangian, L is equal to T minus V. But in the case of Hamiltonian, H is equal to T plus V. Okay. Similarly, from equation 7, we know that dH by dt, that is equal to minus dou L by dou T. Okay. dH by dt, that is equal to minus dou L by dou T. But L does not depends upon the time. But L does not depends upon time. Therefore, minus dou L by dou T is equal to 0. Therefore, dH by dt equal to 0, or differentiation of, or you see H is a constant, or H is equal to constant. When H is equal to constant, differentiation of the constant will become 0. That means what? H is equal to constant, that is T plus V is a constant, hence H is conserved. H is conserved. So the total energy should be conserved. The total energy should be conserved. This is the physical significance. This is the physical significance of the Hamiltonian function. Okay. So in this question, what we saw, what is a Hamiltonian function, how the Hamiltonian function should be derived from the Lagrangian L, from Lagrangian L, and also we found what will be the physical significance of this Hamilton's function. Okay, so this is Hamilton function. Then in the another class I will teach you what is variational principle and how Hamilton function or Hamiltonian equation will be derived from the variational principle. Okay, if you have any doubt, then you ask me in Google Classroom or WhatsApp. Okay, thank you.